all wires and cables will have a small amount of resistance. A resistor has a large resistance in comparison to a wire, which only has a small resistance because it has a smaller concentration of ions. Charge carriers lose energy as the resistance causes the wire to heat up. So energy is lost as heat, and this is due to collisions between the charge carriers and the ions in the conductor. Wires are made with as low resistance as possible to reduce heat loss, but resistance can't be removed entirely. As we know, the power output of a component is given by the current multiplied by the potential difference. So what happens to the heat loss with higher currents? Well, the larger the current, the more energy will be lost to resistance. Remember that current is transported by delocalized electrons that are all moving in the same direction through the wire. The power is given in terms of resistance as P equals I squared times R. We can find this equation by substituting the equation for the potential difference into the equation for power. So the larger the current, the faster the electrons move. Then there are more collisions with the ions and therefore more energy transferred, so there is more heat loss. You don't need to recall why higher currents cause larger power losses in detail for your exam, but you should still be able to apply the power losses to the equation. So what exactly does this mean for cables in the national grid? Large amounts of energy can be lost transporting electricity from power stations to homes. So the electricity has to move a long distance. So the low resistance wires still lose a lot of heat. They're active for a long period of time and there's lots of long wires involved, so the heat loss really adds up. So how can we reduce this heat loss? Well, the national grid uses transformers so that electricity is transported at as low a current as possible. A transformer changes the potential difference and the current of an alternating current. The electricity can then be transported at a large potential difference and a small current to reduce the energy losses, as a lower current means less energy loss to resistance.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!